Hi, this is Leetcode question. Time to cross a bridge, and this is the last question of weekly contest number 327. So in this question, there are two warehouses and a bridge. The first warehouse, which is the new warehouse, is on the left side of the bridge, and old warehouse, which contains some boxes, is on the right of the bridge. And there are some workers who are initially on the left side of the bridge, who wants to move these boxes from the old warehouse to the new warehouse following these rules. The first rule is if a worker X reaches the bridge while another worker Y is crossing the bridge, X waits at their side of the bridge, and that means that if some person is crossing the bridge and there are some workers on the left side or on the right side of the bridge, no one can cross the bridge while this worker did not finish crossing the bridge. The second rule is if the bridge is free, the worker waiting on the right side of the bridge gets to cross the bridge. If more than one worker is waiting on the right side, the one with the lowest efficiency crosses first. So if the bridge is free, and that means no worker is currently crossing the bridge, and there are some workers waiting on the right side of the bridge, and there are workers waiting on the left side, then the priority is for the workers who are on the right side of the bridge, and the one who is less efficient is cross first. And less efficient means that left to right plus right to left greater than left to right plus right to left. And that means, so here we have array represent information for every worker. So here we have k equal to, which is 2 workers, and we have n equal 3, and that n equal 3 means that initially we have 3 boxes on the old warehouse. So k equal 2 means we have 2 workers who are waiting on the left side of the bridge, and for every worker we have this information. This is for worker 0. So left to right plus right to left. Left to right is the first element on the array, so this is left to right, which is the time it takes a worker to cross from left side to the right side of the bridge, and in this case it's 1. And plus right to left, so here is right to left, which is this index, and equal 1. Right to left is the time it takes a worker to cross the bridge from the right side to the left side of the bridge. And so 1 plus 1 equal 2, so the efficiency for this worker is 2, and for this worker is 10 plus 10, which is 20. So 20 is greater than 2, and that means if those 2 workers waiting on the right side, the one with lower efficiency or the higher value crosses first, and in this case worker 1. And if both worker has the same efficiency, then the one with the higher index is considered the less efficient worker and who will cross first. Notice that the other value in the array, this one is the time for this worker to pick the box and return here to the waiting list on the right side. And for this put new, it's the time to put a box on the new warehouse and return to waiting list on the left side of the priority or of the waiting list. Now the last rule is if the bridge is free and no worker is waiting on the right side and at least one box remains at the old warehouse, the worker on the left side of the river gets to cross the bridge. If more than worker is waiting on the left side, the one with the lowest efficiency crosses first, and this condition is the initial condition. As you can see, initially the two workers are on the left side, and there are no workers on the right side, and there are still boxes on the old workhouse, and this means the worker who is less efficient, the worker one, will cross first. And so we need to return the time at which the last worker who carry box reach from the right side to the left side of the bridge. We need to return this time, and so to solve this question we need 4 priority queues. 2 priority queues for the workers at the two houses. These main priority queues are workhouse left and workhouse right, and we will store a vector of 2 values: the end time, which is the time at which the worker finish putting the box for the left, and the time for the worker to finish picking the box on the right side of the bridge, and so we add it to the waiting list on the right side. And the other value is the worker ID, and we need another 2 priority queue, but these are max priority queues, and we will store the efficiency of the worker and the worker ID. So 1 priority queue for the worker who are waiting on the left side, and the other one is for the worker who are waiting on the right side, and we will store vector of efficiency and the worker ID. And it's max priority queue because we need the worker with greater time, who is less efficient, to cross first. And for the worker queues on the warehouses, it's min priority queue because we need to check if the end time is less than a time called busy until, which represent the time until which the current person who is crossing this bridge will finish crossing, which is initially 0. Now at the beginning the workers are waiting on the left side of the bridge, so we need to fill this queue with workers. So this loop we will fill the efficiency and the index of the worker for this to make the workers waiting on the left side. So for the first worker the efficiency is 1 plus 1 plus 1 2 and the index for this worker is 0. For the second worker, the efficiency is 10 plus 10, 20, and the index for this worker is 1. And then we need to loop until the number of boxes in the old warehouses is 0. The first condition here, or the first loop, we check if there are workers on this queue who has end time less than the busy until time. So while this person is crossing the bridge, we need to return the workers who are picking boxes. We want to add them to the right side of the bridge. So this is why we need to check the end time for picking the boxes. It must be the less than or equal to busy until, as we see here. While it's less than or equal busy until, we take the value and we move it to the waiting list on the right side. So we move the worker who is picking the box to the waiting state on the right side. Initially this queue is empty, and so no workers will add it to the waiting list. The second condition is if there are waiting workers on the right side, and that means we need to give them priority. So we will take the worker who is less efficient, and this worker will finish crossing by time busy until plus the time from right to left. So we update the busy until this value, and we will push this worker not to the left queue, we'll push it to the queue of workers who are putting the boxes. So the worker who is carrying this box, we will update the busy until to this value, but we need to add him to this queue. So after we updated the busy until, we will push it to this queue, and that means moving this worker who is carrying a box, we need to decrease the number of boxes remains on the worker on the old warehouse by 1, and we check if the number is 0. That means our answer is the busy until. And here we don't have any worker on the right side, so in the first iteration this condition will not be executed. Now this condition means that if there are workers who will finish, so assume there is a person who is crossing here, and there are workers who are putting boxes on the new warehouse. If the end time is less than the time that this worker finish crossing, we need to put them on the waiting list on this queue, and so this will take workers from this queue into this queue, and initially this is empty. So the first iteration in the first iteration this will not be executed. Now the next condition is if left queue dot size has value, and that means if there are waiting workers on the left side, we need to do the following. We need to check if there are remaining boxes. So if there are here three workers on this queue, that means the three workers will carry all the boxes and no need to send any worker from here. If here, for example, we have a 0 worker, that means there are still boxes that needs to be picked up. And in this case, so if there are workers on the left side and there are remaining boxes, we need to send one of the worker from left to right. So again, this is if no boxes remains. So if right queue empty, if there is no one in the right side to cross, we will give priority to the left side. And work house dot size equal n, that means if there are workers here that equal to n, we will pop the value. We will not send the worker, we just pop it from this queue. Else, as in our case here, there are empty, there are no workers waiting on the right side, and the number of workers here initially is 0. That means this condition will be executed. So we will send the worker with less efficient from left to right. So we will take this worker and we will update the busy until. So let's say we have busy until, which is initially 0. So we will update it by the time it takes from left to right for this worker. We have its ID, the ID is 1, and the time it takes from left to right is 10. So that means this worker will finish crossing at time 10, and we add the worker to this queue because he is going to pick the box. So we will add this time. He will finish picking the box by this 10 plus the time to pick all the box, which is 10. So this worker will finish picking the box at time 10 plus 10, 20, and we push it to this list. So the busy until is 10, and this worker we pop it from this queue and we push here 20. So the time that he finish picking the box, and the ID is 1. Now this condition is just to update the busy time. Let's say there are no workers waiting here, or no workers waiting on the left side, and this means the next time is the minimum from the left, this queue, the time, or this right side. And we do this to update the busy until time for other condition to be applied. Now in the second iteration we'll do the same checking. Now this worker is here, and while right queue, which is this one dot size, and the top is less than 10, no, so we skip this. Right q dot size 0, we skip this. Left q dot size, which is this one, is empty. If left q dot size, it has left q, it has one worker remains, and workhouse dot size is 1, this is 1, is not equal to the number of boxes, so this condition is again executed, and we pick this worker, we send it from this from the left side to the right side, and we update the busy until 10 plus crossing from left to right for this worker, take 1. So we'll update the busy until by 1, and picking old, it will take 9 seconds. So we will push to this queue 11 plus 9, 20, and the index is 0, and because it's min priority queue, this will become first and this is second. Now this condition, if right queue is empty, yes, right queue is empty, and left queue is empty, yes, because the two workers moved. We need to update with the minimum of end time of both, which is 20. So busy until will become 20, which is the end time, you can call it end time. Now we return back in the third iteration, while warehouse queue is has values 2, and the top is less than or equal busy time, so here we have 20 and here we have 20, and this condition is applied. So we need to take this worker from right and adding him to this queue, and so we will add the efficiency for this queue for this worker, which is 1 plus 1, 2, and the worker ID is 0, and also the end time for this one is 20. So again we will add them, but because this is max priority queue, this worker become the first and the other worker is 0. So this queue is empty now. Now if right queue dot size, yes, so we need to move this worker from right to left, and we update the busy time by the time to cross from right to left. So the worker is worker number 1, and the time needs to cross from right to left is 10, so 20 plus 10 is 30, so busy until will be 30, and we push this worker to this queue here, and we will add 20 plus the big pickup or put new time, which is 10, so this become 30 for worker 1, and the number of boxes become 2 instead of 3. That means we moved one box, and we continue the loop because we updated the busy until time, so there is a chance for this queue here that we add more worker to the right side of the queue. So after we continue, so this queue is empty, we return back again to this condition, and we need to send this worker from right to left, and the busy until will update it by, so 30 plus the time it takes for worker 0 from right to left, which is 1. So this will be 31, and we push in this queue 31 plus the time to put the box, which is 8, which is, and 31 plus 8 is 39, and the worker ID is 0, and so on. We continue until we move until n become 0. Let's look into or let's execute the code. And just a small fix for here to check if the boxes in the right warehouse or the number of workers are equal to the remaining boxes. We don't need to check if the right queue is empty, so this must work.